that we had started with the methods of purification, and we have done with the three methods. The first method was dissolving, filtering, evaporating, and crystallizing, and this method was used when the two solids, they are mixed together in such a way that one of the solid that is soluble and the other one is insoluble. Then you can use this technique, and I've told you all the steps in it. The second one was decanting. You use this method when you have got a solid mixed in a liquid in such a way that the solid have got large pieces and they are insoluble in the liquid. Okay, so like pebbles in the water, you can separate them by carefully pouring off the liquid. Okay, and then you have got centrifuging उसमें insoluble particles तो होते हैं, लेकिन वो इतने smaller होते हैं कि वो ना तो नीचे बैठते हैं, फिल्टर पेपर में से भी पास हो जाते हैं, और उसमें हर वक्त सस्पेंशन फॉर्म में रहते हैं. So when you want to separate those suspended particles, you have to do the centrifuging एक मशीन होती है जो कि चीजों को इस तरीके से रोटेट भी करवाती है और एट द सेम टाइम इस तरह रिवॉल्व भी करवा रही है, इस तरह भी घुमा रही है और इस तरह भी एक पर्टिकुलर स्पीड के साथ. Okay, so today my dear, we are going to start with the fourth method of separation, that is called as the separating funnel. So what is the separating funnel, beta? How we are going to use this method? Okay, first of all, this method is used when the two liquids like liquid 1 and liquid 2 or liquid 3, more than one liquids, okay, they are mixed in each other in such a way that the liquid 1, that is immiscible in the liquid 2. Okay, so what does it mean? The word immiscible means insoluble. In simple words, you can call it as insoluble. You people have got the two liquids, okay, and the two liquids, my dear, they are immiscible in each other. वो एक दूसरे में dissolve नहीं होते. Okay, just like you can take the example of the petrol and water. So both are liquids. Petrol is liquid, water is liquid, but both are immiscible in each other. Immiscible in each other means that you are going to mix them together. Okay, so what would happen? The petrol, it will after some time it will start rising up, and water, it will be present downward. Okay, so these two are the immiscible liquids, they do not dissolve. Okay, so if you want to separate the two immiscible liquids, my dear, which are not soluble in each other, you want to separate them, you have to use a technique which is called as the separating funnel. In the separating funnel, what you do? Separating funnel is like that. It has got a tab. So this is the lock or the tab or lock. Okay, so this one contains water. Water is present at the base. Walaikum Assalam. The second thing, that is petrol. Petrol, that is present at the top of the water. Okay, so these two are the liquids. Okay, if you are going to shake them, okay, so what would happen? After some time, the petrol will start rising up, whereas the water, it will remain down. Okay, because these two liquids, they are immiscible in each other, they do not dissolve. Okay, now if you want to separate the water from the petrol, what should you do? First of all, my dear students, you should take a beaker. This is beaker 1. Okay, everybody just look up here. Take beaker 1, just open that tap, the water will start coming out, as soon as this layer is going to start, this will reach up here, this layer. So just close it. So this is your all water. Okay, just take it up there. So this is the beaker one. It contains only water. Okay, now take the beaker two. Okay, in the beaker two, what should you do? Again, open the lock or the tap. So this mixing, this layer mixing of water and petrol, just add it in the beaker two until the petrol that is going to coming out, you should lock it up. Okay, so in the beaker two, you have got the mixing of water plus petrol, and then take the third beaker. Now just open the tap again, the petrol, it will start coming in it. So the third beaker, that is contain the petrol inside it. You got it? So in this way, my dear students, these two immiscible liquids, they could be separated from each other. These two liquids, they are immiscible, they are not soluble in each other. So what should you do? Firstly, you open the tap and water will start coming out. When this layer is going, this layer will come up here. You just stop, you just close the tap and take that beaker side. Okay, so that is your beaker one. Now take the second beaker up here. Again, open the tap. So what would happen? The mixing of water and petrol will enter up here. As soon as the petrol start, you just take it off. So this second beaker contains the mixing of the water and the petrol. And now put the third beaker up here, open it. All the petrol will enter in the third beaker. So this one will contain only petrol. Okay. So you people have got three beakers. In the first beaker, only water is present. In the second beaker, little bit mixing of the water and petrol that is present. And the third beaker, it only contains the petrol. So this method that is called as the separating funnel. You got it? So this is your fourth method. Now the fifth method we are going to start, that is the sublimation. Okay, my dear students, first of all, before starting this method, let me tell you a process which is called as the sublimation. What is the sublimation? In this nature, there are some substances, when you heat them up, there are some solid things. Beta, just listen. इधर सुन लो पहले. कोई बात नहीं, लिखा हुआ है, इसको बाद में स्क्रीनशॉट चाहे ले लेना, just listen. Okay. So if you people have got a solid thing, if you are going to heat them, so what would happen? These solids directly changes into the gas state, into the gaseous state, without passing from the liquid state. Why? Because those solid things, they are having same melting and same boiling point. Okay. Normally, in nature, most of the things, they have got different melting point and different boiling point. Like water is having the melting point 0, boiling point 100, difference of 100 is present. But there are some substances in the nature which have got same melting and same boiling point. Okay, so when you heat them up, so what would happen? Those solids directly changes into the gaseous state without passing from the liquid state. Why? Because they have same melting and same boiling point. Okay, so this process is called as the sublimation. Okay, so just write it down. The conversion of a solid directly into gaseous state without passing from liquid state is called sublimation. The substances solids which sublime have same melting point and boiling point. Okay, and its examples, there are the 4 substances in your syllabus which could sublime, which are present in your syllabus. The first one, my dear, that is ammonium chloride, and its formula is NH4Cl. The second thing, that is dry ice. This one is CO2. The third thing, that is iodine. Okay, and the fourth thing, that is naphthalene. Naphthalene, these are the round white color tablets you often seen when you have gone to the airport on the wash basins, okay, or in the washrooms, they put the white round tablets. Yes, yes, okay, yes. So those are actually the naphthalene. Okay, so people, they also use it as a a rat killer. Okay, they put in the attache cases so that the rats, they are not going to destroy their clothes. Okay, so these are the naphthalene. Okay, so they are the white color tablets. So all these 4 substances, they could sublime. Dry ice, carbon dioxide. If you people have seen in your deep freezers, just listen. If you see, open your deep freezer, what would happen? A smoke that would be formed. So what would happen? Basically, the air which is present inside, it contains carbon dioxide. Okay, so that gas directly changes into the solid state in the deep freezer. And when you open the freezer, so what would happen? The solid ice, dry ice, which was present on the sides of that deep freezer, that will form the carbon dioxide gas to the smoke you could see up there. Okay, so that is actually the dry ice. So these 4 substances, my dear, they could sublime. They are present in your syllabus. Okay. Can I rub this one?
Yes, sir.
Okay, beta. So now we are going to discuss the sublimation method in detail. This is actually the introduction of the sublimation thing I have told you. Now let's start with the sublimation.
सर एक सवाल है
जी बोलिए
सर कार्बन डाइऑक्साइड हमेशा सबलाइन करेगा कभी भी लिक्विड फॉर्म में नहीं आ सकता
डाइऑक्साइड की 2 फॉर्म्स होती हैं बेटा सॉलिड या गैसियस इसकी लिक्विड फॉर्म नेचर में एग्जिस्ट नहीं करती बेटा
ठीक है सर थैंक यू
okay sublimation this technique is used when the 2 solids like solid 1 and solid 2 they are mixed in each other in such a way that the solid 1 can sublime and the solid 2 cannot sublime. Okay, so one of the solid out of these 2 solids, one of them could sublime and the other one could not sublime. So at that time we use a technique which is called as the sublimation. So let's suppose you have got the 2 things which are mixed in each other. The first one, that is the ammonium chloride, and the second one, that is sodium chloride. Ammonium chloride has got the formula NH4Cl, and sodium chloride, that is a table salt. That is the salt you use in your daily life in your kitchen. Okay, so that is the sodium chloride. Okay, so ammonium chloride, my dear students, it could sublime. So these two are the solid things. Okay, ammonium chloride can sublime, whereas sodium chloride, it cannot sublime. Okay, so it means we can use the technique which is called as the sublimation. In the sublimation, what we do, have a look up here. In the sublimation, what we do, we take a dish like that. This is called as the China dish. So the mixture of ammonium chloride and sodium chloride, just put it up here. Sodium chloride plus ammonium chloride. Okay, so this is the mixture, just put it into the dish. Okay, now what should you do? You just put a funnel in an inverted position like that. This is the funnel. It is in inverted position. Okay, now you just heat it up. So what would happen, beta? When you heat it up, ammonium chloride, I have told you it's a solid which could sublime. Sublime means it directly changes into the gaseous state. How it changes into the gaseous state? Have a look up here. So ammonium chloride is a solid. When you heat it up, what would happen? It will break down to form NH3 ammonia gas and one H and Cl, that is the hydrogen chloride gas. So these two gases, they are being formed when you heat it up. So these gases, they will rises up. Okay, so when they touch the funnel, funnel is a cold place. At the cold place, these two gases, they again join together to form ammonium chloride. So your ammonium chloride salt will be accommodated on the walls of this funnel like that. Okay, so all the ammonium chloride present in the dish, that will evaporate and will be deposited on the walls of this funnel. Okay, whereas all the sodium chloride, it will remain within the dish. Okay, now you can take the knife and just scratch this ammonium chloride in some separate dish. So you will get the ammonium chloride separate and sodium chloride is present in that dish. So both of these things, they would be separated. You got it?
Yes, sir.
Okay, so this is called as the sublimation, but this method is only used, my dear, when one of the thing it could sublime and the other thing it could not sublime. Okay, if both of the solids they could sublime, you cannot use this technique. If both the solids cannot sublime, again you cannot use this technique. You can use this technique only when one of the solid it could sublime, it can directly changes from solid to gaseous state, and the other solid does not change into the gaseous state directly. Okay, so then you can use this technique. Okay, so please take a screenshot of it. Can I rub it?
सर
Yes, beta.
सर हमारे पास ये जो अमोनियम क्लोराइड था वो तो पहले सॉलिड में था हमारे पास, तो फिर वो गैस में टर्न होगा ना?
जी बेटा, ये अमोनियम क्लोराइड मैंने पहले ही बताया सब्लिमेशन करता है. इसको जब आप हीट करती हो तो इट डायरेक्टली चेंजेस इनटू गैसियस स्टेट. मैंने तरीका ही बताया है. ये टूट के ये दो गैसेस बना देता है, और जब इनको ये ठंडी जगह मिलती है तो ये दोनों गैसेस जॉइन होके फिर से अमोनियम क्लोराइड सॉलिड बन जाता है. तो इसकी बॉल्स के साथ भी स्टिक हो जाएगा.
ओके सर.
इसको आप किसी भी नाइफ के साथ स्क्रैच करके सेपरेट कर लोगी और सोडियम क्लोराइड यहाँ पे रह जाएगा. कैन आई रब इट? Can I
Yes,
have-
sir.
Yes, sir.
Okay, guys, the sixth method, that is simple distillation. Okay, guys, what is the simple distillation and how we are going to use it? When a solid and liquid, they are mixed in each other in such a way that the solid, it is soluble in the liquid, then you can use this technique which is called as the simple distillation. Okay. Yes, बेटा।
फ्रैक्शन डिस्टिलेशन भी होती है ना, फ्रैक्शन।
जी जी बिल्कुल होती है, वो बाद में डिस्कस करते हैं, पहले simple distillation. Okay, my dear students, so the simple distillation is a technique which is used when one of the solid, it has been dissolved in the liquid in such a way that the solid is soluble in the liquid. Then you can use this technique. Its example, you can take like salt plus water. Okay, so salt is a solid thing and water, that is a liquid thing. Liquid, it's a solid thing, and the salt, that is soluble in the water. Okay, so it means if you want to separate the salt and the water, you can use the simple distillation. In the simple distillation, my dear students, what you do, you take a round bottom flask like that. So this is the round bottom flask. Okay, so put the mixture of this salt and water up here. Salt plus water. Now there is a bung. Bung is actually a stopper. It's called as a stopper. Okay, so this stopper has got one opening through which the thermometer, that is being inserted in it. So this is the thermometer. And there is another opening through which a condenser that will come out. So this is the condenser. The name of this instrument, that is Liebig condenser. You can call it condenser only, but Liebig condenser, that is the perfect name. It Liebig is actually the name of the scientist who discovered it for the first time. And what is the function of it? I'm going to tell you a little bit about it. Okay, my dear, have a look up here. There is one more thing I'm going to draw. So this is the receiver flask. Okay. Okay, everybody now just focus. Okay, beta, first of all, this is the round bottom flask. It contains salt and water. What we do, we are going to heat it up. Okay, so when we are going to heat it up, what would happen? The temperature of salt and water, it will start increasing. Okay, and a time will become when it will start boiling. Anybody could tell me at which temperature this solution boils?
100 degree.
100.
102, 103.
Yeah, 102 and 103, not at 100. Because pure water, my dear students, it has got 100 boiling point. But I've told you at the start of the chapter, if you add any impurity in the water, it will decrease its melting point and it will rise its boiling point. So boiling point will rise. So this type of question has come in the paper 4. Okay, they have taken the sea water up here and they will ask you at which temperature the sea water boils. So most of the students just see water, okay, and they said it's 100 degrees Celsius. That is wrong. Sea water contains the salt inside it. It will start boiling at a temperature more than 100. So 102, 103, 104, whatever the thing value you could write. Okay, so it will start boiling. Okay, when it will start boiling water, it will form the vapors. So these are the vapors of the water. So these vapors, they will enter through that Liebig condenser. The function of the Liebig condenser, it condenses the vapors back to liquid. Okay, so these vapors are actually the gaseous form. So these gaseous vapors, when they pass through the condenser, the cold water will go inside. It will revolve around that tube. This is a tube around which the cold water that is running, and this water will go out from that place. So always keep remember, against the gravity, water in is present and water out is present. It shouldn't be like that. Water out should not be up here, because if water in is this, water out is this, you just join it with water. Due to gravity, this water will not stay within the tube, it will come out. But if you connect the water in up here, this will rise up, it will stay a little bit inside it, and then it will go out. Okay, so keep remember, water in and water out, they are always present in that direction. Okay, it shouldn't be water in up here, water out up here. In papers, mostly they ask you about the errors. So they write water out up here, water in up here. That is the wrong thing. Okay, always water in and water out, they are against the gravity. Okay, so water vapors, when they passes from here, okay, so the cold water is going to flow around that tube. So due to coldness, these water vapors, they condenses into liquid, and these droplet of the liquid, they will fall down up here. So you will get the water up here. I'm going to give you one example. If you have taken a cold glass of water, guys, just listen. If you have taken a cold glass of water, okay, you just put it. So what would happen after some time? The outer surface of that cold glass, it contains the water. Okay, so from where that water has come from? Has it been leaked from inside? No. In the air, water vapors are present. When they find the cold place, these water vapors, they are going to condense. Okay, and that water has come from the air. The water coming from the air conditioner, that is also how it is coming. The cold pipes, around the cold pipes, air is present. Air contains the water vapors. So those water vapors will condense at that cold place and will form the water droplet. Okay, so the same thing would happen up here, my dear students. When this one will start boiling, the water vapors will rise up, goes into the Liebig condenser. The function of the condenser is it condenses the vapors back to liquid. Vapors mean gaseous thing into the liquid thing. Okay, so these liquid droplet will fall down into the receiver flask. You will get the water separately, whereas all the salt present up here, it will be accumulated up here. Okay, so the two things, they would be separated. Your water that is present in the receiver flask, whereas your salt that is present in the round bottom flask, and the two things, they are being separated. You got it?
Yes, sir.
Okay, can I rub it?
Yes, sir.
Yes, sir.
Okay, my dear students, the next technique, the next thing, that is the fractional distillation. Fractional distillation, that is a technique you people are going to use it when the two or more than two liquids which are miscible in each other. If the two liquids, they are soluble in each other, we use the word miscible. But if one of the solid and other thing is liquid, they are soluble in each other, we use the word soluble for that. Okay, for liquids we use the word miscible technically. Okay, and if the two liquids, they are not soluble in each other, we called it as immiscible. And I've told you how to separate the immiscible liquid by the separating funnel. Okay, but if the two or more than two liquids, they are mixed in each other in such a way that you are unable to see that where your liquid one is and where the liquid two is, they are properly mixed, they are miscible in each other. And if you want to separate them, okay, and these two liquids, they have got different boiling point. Let's suppose its boiling point is 54 degrees Celsius and its boiling point, that is 78 degrees Celsius. Okay, so both of these liquids, if they have got different boiling points, then you can use a technique to separate, which is called as the fractional distillation. If the two liquids, their boiling points are almost similar. Let's suppose this one is 54, this one is 54.1, almost same. Or this one is 54, this one is 55, only 1 degree Celsius difference. Then again, if the two liquids, they have a difference of boiling point at least 5 degrees Celsius, then you can use this technique. Okay, because if the difference is very small, then you can't separate the two liquids by that method. You got it? Okay, so this method is only used when the two liquids, they are mixed in each other in such a way that the liquid one, that is miscible in the liquid two, then you can separate them by the fractional distillation. The detail of fractional distillation we will study tomorrow because it's a very important topic. Okay, so tomorrow